Welcome to the DIY Honda Garage channel. The diagnostic trouble code DTC P0010 relates to a malfunction within the variable valve timing control (VTC) oil control solenoid valve in the Honda Civic model from 2022 onwards. The VTC system optimizes engine performance by adjusting the timing of the intake camshaft based on driving conditions. This adjustment helps improve fuel efficiency and reduce emissions. When the powertrain control module, PCM, detects a discrepancy between the commanded and the actual current flowing through the solenoid, it records this anomaly and triggers DTC P0010. It's essential to address this issue, as a malfunctioning VTC solenoid can lead to poor engine performance, increased emissions, or potential engine damage. The proper functioning of this component is vital for maintaining optimal engine operation across various speed and load conditions. DTC P0010 indicates a malfunction in the variable valve timing control oil control solenoid valve A. The solenoid's primary role is to manage the flow of oil to the VTC system, impacting how the camshaft timing is adjusted. When the PCM detects that the commanded current differs from the actual current flowing through the solenoid, it identifies this as an abnormality. This abnormality can hinder the solenoid's proper function, leading to unsatisfactory engine performance. The location of the VTC oil control solenoid valve A is typically situated near the engine's cylinder head, making it accessible for inspection and replacement. Understanding the component's location and function is crucial for effective troubleshooting. Several factors can lead to the triggering of DTC P0010. A primary cause is a defective variable valve timing oil control solenoid valve A, which may fail to regulate oil flow properly due to internal wear or electrical failure. Additionally, issues in the associated wiring, such as short circuits or open wires, may disrupt the electrical signals necessary for the solenoid's operation. It's vital to inspect the VTC in and PG circuits for any wiring-related problems. Finally, if the solenoid and wiring check out, a malfunctioning PCM could be the culprit, as it is responsible for processing input signals and regulating the engine's performance accordingly. The PCM itself can suffer from failures that may require replacement or reprogramming. The symptoms associated with DTC P0010 can significantly affect vehicle operation. A common symptom is the illumination of the check engine light on the dashboard, indicating that a fault has been detected. Drivers may also experience rough idling, where the engine runs unsteadily at low speeds. Additionally, a decrease in overall engine performance can be evident, manifesting as sluggish acceleration or loss of power during drivability tests. Finally, poor fuel economy may result due to inefficient engine operation, where the vehicle consumes more fuel than normal. Addressing DTC P0010 promptly helps mitigate these symptoms and prevent potential long-term engine damage or performance degradation. The first troubleshooting step for addressing DTC P0010 involves starting the engine and allowing it to idle. The technician should maintain the engine speed at 3,000 RPM without load, meaning that the transmission must be in park or neutral for automatic transmissions or in neutral for manual ones. This action continues until the radiator fan activates, ensuring the engine reaches the necessary operational temperature for accurate diagnostics. When the fan comes on, it generally indicates that the engine has achieved an optimal operating temperature, allowing for the current to be read accurately from the VTC oil control solenoid. Following this step is crucial, as it sets the baseline for the subsequent diagnostic steps in assessing whether the VTC system is functioning correctly. In the second troubleshooting step, the technician must disconnect the VTC oil control solenoid valve A, specifically its 2-pin connector. This disconnection is necessary for accurate testing of both the valve and the circuits associated with it. The next action is to inspect the connector terminals visually for any signs of corrosion, damage, or debris, all of which could lead to poor connectivity. After confirming the condition of the connector, the technician should perform a continuity test using a multimeter to measure the resistance within the solenoid. Ideally, the resistance should fall within the range of 7.01 to 7.75 ohms at room temperature. If the measured resistance deviates from this range, it indicates a fault in the solenoid itself and suggests that replacement is necessary. In this third troubleshooting step, preparation for inspecting the wiring circuits is critical. Initially, it's important to ensure that the VTC oil control solenoid valve A connector remains disconnected. Following this, the technician must also disconnect the PCM, Powertrain Control Module Connector, E, which typically consists of 80 pins. This disconnection allows for safe checking of the circuits without interference from the PCM itself. The next part of the process entails inspecting the wiring of the VTC in and PG circuits for any open wires or shorts. A normal condition would show less than 1 ohm of resistance. Thus, if the readings are higher, or if there is a short to ground, further investigation into the wiring is essential to confirm the integrity of the circuit. In the final troubleshooting step, assuming that all prior inspection items yielded normal results, the focus shifts to the PCM's functionality. The PCM is responsible for processing input signals from various sensors, which in turn modulate engine performance. If the previous tests confirmed the VTC oil control solenoid and the wiring are in good condition, yet DTC P0010 persists, the PCM may be at fault. Technicians will utilize diagnostic tools to verify if the PCM is performing its duties correctly. If abnormalities in functionality are discovered, such as failure to execute commands properly, this indicates a problem with the module itself. Depending on the finding, further actions may include reprogramming or replacing the PCM to resolve the issue and restore the vehicle's performance. Once the necessary repairs have been made, a final verification step is crucial to ensure that the issue has been resolved. The first action is to clear DTC P0010 from the vehicle's computer system. Clearing the code resets the system and allows for fresh readings. Next, a test drive should be performed under various conditions to ensure that the engine operates smoothly without any performance glitches, and that no warning lights reappear on the dashboard. Monitoring the vehicle during this test is vital to confirm that previous symptoms have vanished and the repairs are functioning effectively. If DTC P0010 does not return after this test, it can then be concluded that the repair process has successfully rectified the issue. Preventive maintenance plays a crucial role in avoiding issues like DTC P0010 in the future. Regular inspections of the VTC wiring and connector are essential, as they can prevent corrosion or damage that may lead to circuit issues. Additionally, maintaining proper engine oil levels is vital because the variable valve timing system relies on adequate oil pressure to function efficiently. Keeping fluids at recommended levels not only promotes the performance of the VTC system, but also supports overall engine health. Moreover, adhering to a schedule for timely oil changes ensures that the engine remains properly lubricated and minimizes wear on components, including the VTC oil control solenoid. In summary, consistent maintenance and timely inspections can greatly extend the longevity and reliability of the vehicle's engine performance. In conclusion, DTC P0010 signifies a malfunction in the variable valve timing control oil control solenoid valve A, which plays a critical role in engine performance optimization. Addressing this DTC involves systematic troubleshooting to identify whether the issue lies within the solenoid, the associated circuits, or the PCM. By following the outlined steps, technicians can effectively pinpoint the source of the malfunction and perform necessary repairs to restore the system's functionality. Additionally, staying proactive with preventive maintenance practices aids in minimizing the risk of similar issues in the future. Overall, understanding how the VTC system operates and implementing regular checks can significantly enhance the reliability and efficiency of the vehicle. Please like and subscribe to the channel. See you next time.